My name is Javed and I'm a software professional. Being an engineer, I know how fast the world is moving with amazing technologies and innovations. Being a father, I aspire to give the best education to my kids in this fast moving world. So I do closely monitor my children's education and help them understand the concepts in best possible way. Often we see kids struggling with mathematics subject while doing calculations, problem solving and so on. I was looking for some easy methods to make them feel to solve the problems with ease. So while during this process of searching good content, I came across a book written by a renowned mathematician. And I found that book very fascinating and the tricks explained for regular mathematics is simply amazing. One may think that there are enormous number of videos on matrix, then why another one? I saw many videos of matrix on YouTube. Some explain the tricks specific to some format or number or some specific methods which is applicable for 2 digit or 1 digit or 3 digit. In this series of videos, I will give an example of a rule and a generic methodology which can be applied for any scenario. Yes, of course, there are few videos where these methods are explained as well. In this video, I tried to explain in a bit detail with clear illustration in a way even a grade 2 student can understand well. You will definitely witness it after viewing this video completely. So let's begin. First topic is doing a multiplication without using tables. To get familiar with the method, let me take you through a simple 2-digit multiplication without using tables. How to do multiplications with a method that I'm calling it as a regular method. We all were taught in school studied by memorizing tables. And using the tables, math calculations are worked out. Of course, it is must and very much necessary to memorize tables to perform math calculations, and there is no alternative for that. But what if I tell you there are methods to perform multiplication without using tables at all? This sounds interesting, isn't it? Let's see how. To understand better, I will consider the simplest example first, that is 11, followed by 12. This will give a picture of the methodology and how it really works. This method needs only addition and subtraction. We'll explain all the single digit multiplication in the next upcoming video. Before we go through the method, it is very important for us to have the basic understanding of the steps to apply the rule. Here I'm going to consider an example 2314 into 11. So here the 2314 is called as a multiplicand and 11 is a multiplier. So always consider multiplicand to apply the rule from rightmost digit towards the leftmost digit. So we will start working on digit by digit from right to left. So we will have to first take the number 4, apply the rule, then go to the next number 3, then go to the next number 1, apply the rule, and then to the last most digit as 2. Okay, and also we have to consider appending 10 to the multiplicand, that is our multiplicand should be 02314. So here the steps in this particular step by step process, we need to apply the rule from 4, 1, 3, 2 and 0. Okay, and the best practice would be that whenever you're working on the number 4, it is always a good practice to write the result right below this particular number. So always write the result exactly below the digit of the multiplicand, and it gives a very good readability and also ease for validation when you are, if you want to validate your multiplication is correct or not, then it's easy for readability as well and ease for validation. It gives an ease for validation. And during this when you're adding any number, if you get a double digit, then it is always we will have to carry forward that particular number for the next digit, and if any, carry forward to the next and proceed with the next digit to apply the rule. Likewise till 0. And we have to understand there is a term called neighbor. Neighbor here means like the number which is right next to the number is called as a neighbor. For example, in this particular 2314 example, 4, there is no neighbor for 4 since there is no rightmost digit applicable in this example for 4, so there is no neighbor. And 4 is the neighbor of 1 is the neighbor of 3, and 3 is the neighbor of 2, and 2 is the neighbor of 0. Okay, so this is how these are the basic rules that we need to know before applying the method. Going to see an example of a multiplication with a multiplier 11 and a 4-digit multiplicand number. Here is the rule for the multiplication of any number with the number 11, that is, add the neighbor. Here I'm considering one example 2314, and this doesn't have any carry forwards while we are applying the rule. So as I mentioned, we have to start working from the number from the rightmost digit towards the leftmost digit. So considering that, we have to start working from 4, the digit 4. The 4 here, the rule is to apply the add the neighbor. So 4 plus there is no neighbor for it, so we'll have to add 0. Then it is 4 plus 0 is 4, and then we are going to the next digit 1, and here the neighbor of 1 is 4. Then you have to add the number 1 plus 4 equals 5, which is written here like rules applied, and I have clearly mentioned that how the rule is getting applied here by considering this particular digit and adding the neighbor. Similarly, we are working on 3 now, and the 3 plus 1. So for 3 the neighbor is 1, so we have to add 3 plus 1 is 4, and then coming to 2 plus 3 is equal to 5. And here we should not forget that we should work on the last digit, that is 0 as well, because the rule itself says that you have to add a neighbor. So for even if we consider a 0, we will have one particular number, I mean the neighbor will also be applicable, so we will have to consider a 0 in the last digit, and then we will have to apply the rule. Then 0 plus 2 is equal to 2. So finally the answer would be 25454 when it is multiplied with 11 into 2314. Here is another example of multiplying a number 4-digit number with 8449 into 11. Here this example is mentioned specifically to show you how the carry forwards will be worked out in this example. So here we will start with the number 9, though there is no neighbor for the number 9, so it is 9 plus 0, it's 9. And then for the next digit it is 4 plus 9 equal to 13, so we'll have to keep 3 here, and then we will have to forward the carry 1 to the next digit. And when we are adding the 4 plus 4, it becomes 8. Then we will have to add this carry 1, then it is 9. And when we are going to the next digit 8, here 8 plus 4 equal to 12, and we'll have to keep 2, and we will have to carry forward the number 1 towards the next digit. And then here we will be having 0 plus 8, and then we'll have to add this carry, then it is 9. So the answer is 92939. And here I am just showing you the 11 table, and this can be derived for using that method itself. Like while we can apply the methodology or the rule of this 11 on this particular table, and we will attain the same result. So if you can see here like 0 and 1, so if I consider 1, then the answer would be that there is no neighbor, so 1 plus none equal to 1. And then when you are applying at 0, then it is 0 plus 1, so the neighbor is 1, so we are adding it as 0 plus 1. So this you can see that 1 and 1 is coming like this answer. So similarly 0 2 into 11, and you can see there is no, since there is no neighbor for any of these digits, so you will get the number as it is. And in the next number, all the zeros are there, and then when you are adding the neighbor, it will be the same number. So until 9 you can see the numbers are getting repeated. So if it is 1, then you will have 1 and 1, 2 2 2 3 3 3, like that until 9 you can see 9 9. And let's see for an example of 10 how it works. So we have, as I mentioned, for any number that we will have to append a 0 before that number, so we will have to consider a number like 0 1 0. In this case, when we apply the rule at 0 at this particular digit, then it is 0 plus none, so it is 0. and then when we are going for 1, then we will have to add 1 plus 0, then it is 1, and then here again we will have to add 0 plus 1, then it is 1. So 10 equal to 11 equal to 110. So this is how the whole 11 table can be derived using just this table, and you can apply, and you can see applying this particular 11 even for any number, and you will attain the same result. Let's see the rule for any number multiplication with the number 12 in this case. And the rule for multiplication of any number with 12 is double the number and add the neighbor. So here I'm considering an example with no carry forwards. So the number is 2312 into 12. So here we will have to start working from right to left. So starting from the number 2. So the rule is that we will have to double the number and add the neighbor. Here the number is 2. We will have to double the number, that is 4, plus there is no neighbor, 0. So answer is 4 and 1. So we have to double the number 2 plus add the neighbor 2, then it's 4. Then 3 into 2 6, 6 plus 1 7, and here again 2 into 2 4 plus 3 equal to 7, and here again 0 into 2 is 0 plus 2, which is 2. So the answer is 27744. One example with carry forwards. So here I'm considering a number 8449 into 12. So here we will have to apply the rule starting from right to left. So considering 9 into 9 plus 9 equal to 18, plus 0 is 18. So we will have to keep the 8 here and then carry forward the number 1 to the next digit, and then 4. 4 plus 4, 8. 8 plus 9, the neighbor, and plus 1, the carry forward. It is 18. We'll keep the 8 here and 1 carry forward. Then again 4 into 4 plus 4, 8. 8 plus 4, 12, and plus 1, 13. So we'll have to keep 3 here and 1 carry forward to the next digit. Then 8 into 8 plus 8, 16, plus 4 and plus 1, the carry forward, which is 21. So we'll have to keep 1 here and 2 here, and then you will have to apply the rule that the 0 is 0 plus 0 plus 8 and then plus 2 is equal to 10. The answer is 101388. You can see the same rule applies for even for the tables, and you can attain the same results using this table, using this particular rule on the table as well. So if you see 0 and 1, so the rule is double the number and add the neighbor. So when it comes to 1, you are doubling the number, 2 plus none equal to 2, and then here then 0 into 2 is nothing, 0, plus the neighbor 1. So in simple terms you can say that all these numbers are getting doubled. So 1 becomes 2, 2 becomes 4, 3 becomes 6, 4 becomes 8, like that. So and the next number is just adding the number, adding its neighbor to it. So here what we need to see here is when it comes to 5, so when we are doubling it, it becomes 10. So the carry forward, you will have to we have to keep the number 0, and then you will carry forward the number 1 towards the next number. So it means that here you can see that the number becomes 5 plus the carry forward is 1, so it is 6. So in this way you can get the result. And if you see that till 4, it's a direct number that you will get 4 and double the number 8. And here you will see a carry forward which is going 1 towards it, and then you will be adding this number. So you can see the next number here, mostly the 5, it will be 6 here, 6, 7, 7 and 8, and 8 and 9, and 9 and 10, because we are adding a carry of the previous number. Similarly, if we consider an example of 0 1 0, so here also you can see that when we are doubling the number, it is 0, then we are going to double the number here and then adding the neighbor, then it is 2, and then here we are adding the neighbor to it, that is 0 plus 1, it is equal to 1. So the answer for 10 into 12 is 120. You have now understood how to apply the rule, and in this particular video I have considered a very simplest examples of 11 and 12 where the rules are simple, that add the neighbor, and for 12 it is double the number and add the neighbor. And similarly we will have a rules for each of these numbers, basically for the numbers from 4, 5, 6, 7, 8, 9 and 3, and they have you will have to apply a rule, simple rule for each of these multiplications. However, when we go for the multi-digit multiplications, you don't have to memorize any rules, but you will have to follow an approach which works for any number of digits and any number of digit multiplications. So in the upcoming videos, I'm going to consider I will go through these topics like multiplication of multi-digit numbers and the single digit multiplication using the simple rules, and then division method and the square roots. In regular method, the multi-digit multiplication or division method involves multiple steps to attain the final result. It means that when we are doing a long lengthy number or a 5 or 6 digit number multiplication with a 3 digit number, then we will in a general method we will first apply the result. We will first attain the result for one particular digit, and then followed with other digit, and then followed with other digit. Then we will sum up all these numbers, and then we'll finally attain the result. But however, by applying this particular methods, these are the methods where we are focusing only on the final result, and all the intermediate steps will be calculated in mind. So you will have to calculate all those intermediate steps mentally, and you will be focusing only on the result, final result, and you will put it on the paper. So this is how it benefits to work on the problems or the methodologies much faster than the regular method. Pretty sure you will be amazed with these methods if you haven't come across any time. These are the amazing outcomes of a great renowned mathematician by name Trachtenberg. Make use of it to enlighten new generations with these methods. And do share if you find this content useful. Thank you.